All right, folks. How's it going? Happy Friday. Depending on what time it is, surgery starts at 8 a.m. So either I'm out of it or I'm in it. But there you go. So here's the deal, folks. Today, all right, hopefully if you're watching this video, you've already started kind of what you're supposed to do, all right? You've gone to the week at a glance. You've started this video. Make sure to watch the whole thing. And when you're finished, get started on that Friday, the 4.4 Friday assignment, okay? Now, I'm going to show you all how to do some of the questions in the assignment, but also I'm going to go over a little bit of the lesson, okay? So first off, we've got our lesson here, right? It's more balanced moves. The goal today is I want y'all to be able to make sense of multiple ways to solve an equation because there's never just one, right? So as you can see here, right, which equations have the same solutions as equation 1, right? We can answer those, y'all can solve them. We can get equations that equal the same thing, right? Where x is the same thing, but the equations look different. I more want to go over this step by step. Okay, so we've got two equations. Claire wrote one, Lynn wrote the other, and they're solving them step by step. Okay, so let's see who did it right. Okay, so we can tell here, right? Obviously, first, we probably want to combine like terms. All right, that's one of the tools we're going to be using today. Is we're going to combine like terms. Then we're going to distribute, and then we're going to be using, well, distribute meaning the distributive property, and then we're going to use inverse operations, okay, to solve the rest. So what it looks like Claire did here, and feel free to go ahead if you haven't already started or haven't already like figured this out, right? We can start by combining like terms, right? That's what Claire did. She's combined this 14x with this minus 2x to get 12x, right? That's that initial step. She combined like terms. Okay, the following step's kind of funky. She almost undistributed this, okay? So 12x plus 3 is the same as 3 times 4x plus 1. If we distribute this, 3 times 4 is 12x, 3 times 1 is positive 3. So she kind of went backwards there, which I thought was really interesting, okay? Because then it looks like she divided by 3 on both sides, all right, just to get rid of the 3's in front. It's not a bad way to do things. It's not my way of doing things, but it's not a bad way. Okay, looks like then she subtracted 4x from both sides. All right, 4x minus 4x is nothing. 5x minus 4x is just x. So you end up with 1 is equal to x plus 9. Then we can simply use those inverse operations. Again, it's telling us to add 9, so we're going to subtract 9 because don't tell me what to do, right? Subtract 9, and we will get that x is equal to negative 8, okay? Not wrong. She did it correctly. That's great. So here, pretty much, we're just identifying what steps do. Again, pause the video. Try to see if you can get the steps on this one, all right? So if you've paused the video now, if you were playing it, I'm assuming that you finished this, right? Looks like here we are again combining like terms. Safe bet. Good thing Lynn did. All right. And then here, Lynn's kind of on our same page. And the next step, it looks like Lynn distributed. 3 times 5 is 15x. 3 times 9 is 27. All right. We're on the same page. Okay. Now on this step here, it looks like we subtracted 3 from both sides. It's an inverse operation. They're telling us to add 3. We want to get rid of the 3. That's what we've identified as the number we want to get rid of. So we're going to subtract 3 from both sides. That'll give us 0 on this side for 3. And then 27 minus 3 is 24. Now again, we are only able to subtract 3 from 27 because 3 does not have an x. There's no variable there. We cannot subtract 3 from 15x because 15x has a variable, right? Those don't mix. All right. So then we get down here and it looks like we have subtracted 15x from both sides. Now, because we want to get rid of that, we want our variables on the left side. We've got negative 3x equals 24. If we divide both sides by negative 3, we do in fact end up with x equals 8, which is the same as what Claire got. So they're both right. Okay, so that was a very quick run through of how to do this. I want to show you all a little bit in more detail kind of how to do this. All right, so I'm going to go down. We're going to get some help from an old friend. Yes. I'm getting a call. I don't need to answer that. All right, solving equations. Y'all don't have this worksheet, and it's okay. If you want to grab a scratch piece of paper and take some notes, that's fine. Okay? No worries. Phyllis is here to help us out and support us in this endeavor. Is that right, Phyllis? Oh, very good, Phyllis. Don't say that, Phyllis. It'll offend somebody. Anyway, so solving equations, the first thing that I always do, me personally, is distribute. All right. Now, is it the only way to do it? No, you don't have to distribute first. Personally, that's how I do it. Just because I like to get rid of parentheses, I like to abide by PEMDAS in all the things that I do. So I'll distribute and get rid of parentheses, right? So negative 2 times 3 is negative 6x. Negative 2 times that minus 5 is actually going to change the sign to a positive, right? Because a negative times a negative is a positive. So negative 2 times negative 5 is positive 10. That minus 4x is still hanging out there, and it's equal to 20. Okay, fair enough. All right, now, the next thing I like to do, as you can see, I've got a lot of terms here. All right, I've got this negative 6x. I've got this negative 4x, right? These terms are alike. So what I'm going to do is I'm going to combine like terms next. Combine like terms is the next way I do this, all right? Now in combining like terms, negative 6 minus 4x, or negative 6x minus 4x is going to get me negative 10x, okay? Plus 10 equals 20, all right? Now here I kind of have a decision to make, all right? It's been made for me, but I got to figure out which side of the equal sign I want my variables on. I usually move my variables to the left, right? Move variables to the left side. Now I move things around using inverse operations, okay? As you can see, my variable, oh, that was close. Holy cow, that was scary. As you can see, my variable's already on the left side. I'm going to keep it there. That's fine, all right? If I had a variable on the other side, like for example, if this was plus 5x, I would just use inverse operations to subtract it from both sides, all right? Now, I don't have a variable over there, so I don't really need to move my variables around, okay? But I'm going to move all of my constants to the right side. Okay? Now when I do that here, I'm again using inverse operations. That means 10 and 20, any number that doesn't have a variable is a constant. Okay? So here, I'm going to use inverse operations. They were telling me to add it. Forget that, man. I'm going to subtract it. Do my own thing. From both sides, because we want to keep this balanced, right? We end up with negative 10x is equal to 10. Huh. What multiplied by negative 10 will equal a positive 10? Well, if we're not sure, we can always divide both sides by negative 10, right? That final inverse operation, multiply and divide, right? And we'll get that x is equal to negative 1. All right? Now, what I should be doing when I get this answer is going back to check my answer, right? That's what Phyllis said anyway. Phyllis knows what's best. Right, Phyllis? Do you know what's best? Oh, geez, Phyllis. Phyllis, calm down. Come on. Goodness gracious. Anyway, so we can go back and check that answer, right? If we put in negative 1 for x, a few things will happen. Oh, geez. So let's try that. Negative 1 for x. 3 times negative 1 is negative 3 minus 5 is negative 8 times negative 2 minus 4 times negative 1. Goodness, so this is going to be positive 4, right? Negative 4 times positive 4. I'm going to do this in a different ink. This is just kind of confusing. Also, that keeps happening. Ugh. Oh my gosh, no. Anyway, y'all. So if I put in -1 times 3 is -3 minus 5 is -8. We still have to multiply that by -2. -4 times -1 equals 20. All right, let's test that out. Let me make some more room. We'll erase some more stuff. Okay, so always check your answers, folks, because it's like asking me if you're right. Okay, so I'm not always there, so you can just check yourself, right? Input that solution into x and c. So -2 times -8 is +16. -4 times -1 is going to be +4. And does 16 plus 4 equal 20? Yes, in fact, it does. So we're good. All right, that is x equals -1 is the solution here. Phyllis approves. Phyllis, do you approve? All right, way to go, Phyllis. Phyllis is also dabbing on those haters, so make sure y'all are doing that. Okay. All right, folks, so that is generally how we do this, okay? Make sure you're also celebrating once you check your answer and you get that it's right, okay? So, class, the rest of the time is yours. This is 11 minutes, so it's a little bit over the video length that I wanted to go through, but that's okay. All right. If y'all have any questions, we can talk about it on Monday. Monday's class, we're going to be going over a very similar thing. We're going to be doing more work on equations. So if you're not sure about this, don't worry about it. We got class Monday to talk about it too. Okay? All right. Y'all take it easy. Have a fantastic weekend. Do something fun. Do something crazy. And I'll see you all on Monday. All right? Bye-bye.